The title is Multiplying and Dividing Rational Expressions. Last time we did Simplifying Rational Expressions. So our next test will be on simplifying, multiplying and dividing, and adding and subtracting rational expressions. The central question is, what are the steps to multiply rational expressions? What are the steps to multiply rational expressions? And how is multiplying different than dividing rational expressions? How is multiplying different than dividing rational expressions? Okay, we're going to step it back to multiplying regular fractions because we talked about in our last set of notes that a rational is anything that can be made into a fraction. And we're dealing with polynomials and fractions. But let's practice multiplying regular fractions. Who can give me a fraction? We're going to need a bunch of fractions today. Tyler, give me a fraction. Over what? Over 50. 23 over 50 times, someone give me a little bit smaller fraction. We're going to have some difficulty. 1/2, that sounds great. Okay. 1/2. So, how do we multiply fractions? Right? Who said it? Noah, was that you? Or Austin? Straight across, right? So we do 23 times 1, which is 23. And 50 times 2, which is 100. Yeah, not divided, times. Okay, so we multiply straight across, and we always have to check and see if it simplifies. Does 23 over 100 simplify? Yeah. What can we simplify them by? What divides into both 23 and 100? Only the number 1, right? So the answer here was no, they didn't simplify. They don't simplify. Okay? Let's review dividing fractions. Dividing fractions. Someone on this side, give me a fraction. 3/4. Okay? 3/4 divided by, one more fraction, Haley? 9/18. All right. How do we divide 3/4 divided by 9/18? Do we just go straight across like multiplying? We what? Okay. I guess we could call it that. We usually call it something else. Tyler? Flip and multiply, right? And so we flip the second one. And today I'm going to, someone yesterday was a genius and taught us a new phrase for flip and multiply, which actually might be a little more clear. The problem is, students often flip the wrong one. They flip the first one, and that's not what you're supposed to do. You always flip the second one. And then it becomes a multiplication problem. So then we just do what we did on the first one and go straight across. What's 3 times 18?
50.
Okay, and 4 times 9? Okay, since they're both even, I can tell right now it does simplify. 54 divided by 36. What would go into both 54 and 36? Okay, so divide 54 by 9, we get 6, right? Divide 36 by 9, and what number do we get? 4. It looks like it can simplify even further. 3/2. Good. Okay? So that's review. Does anyone have questions on multiplying or dividing fractions? Okay, now we're going to actually do that with our polynomials. So, first example. All right. Example 1, we're going to find the product and state excluded values, like we did on our last lesson. So the first fraction is x divided by x minus 2. X divided by x minus 2 times another fraction times x plus 1 divided by x minus 3 times x plus 1 divided by x minus 3. Okay. So, the first thing I'm going to ask you to do in all of these problems is whenever we see a binomial, we're going to put parentheses around it. So, do you see any binomials that we need to insert parentheses around? Binomials. Binomial has how many pieces? 2. Okay, so where do we have a binomial? Paula? And give me one example. X minus 2 is a binomial, right? Where else do we have a binomial? X plus 1 and Tyler? Good. So we have 3 binomials, right? The reason I'm asking you to put parentheses is because we're looking to find things that cancel to make it simpler. And we can only cancel if the neighbor is being multiplied. So for this x plus 1, with the parentheses, you can see that the neighbor is being multiplied. And x minus 2 is being multiplied to x minus 3. Okay? So currently, do we have any matches that we can cancel? Because there's a match top and bottom. No, we don't. So we just have to find the product, which we just reviewed how to multiply fractions. We go straight across, right? So it becomes x times x plus 1. What's x times x plus 1? Plus x. Good. Any questions on how we got x squared plus x? Then the next one, we go straight across again, and we do x minus 2 times x minus 3. Now this one's not as easy as the numerator because how do we multiply 2 binomials? Yeah, and we distribute twice, so we call that double distribution. Okay, so we need to do x times x and x times negative 3. Spouse? Okay, you're way ahead of us. But yes, that will be the ending. X times negative 3 is negative 3x, right? And then we have another number to distribute. Okay, Amy, what else do we need to distribute in? Negative 2. Negative 2 times x and negative 2 times negative 3. Emmanuel, what would that give us when we multiply the negative 2 into both? Good. And when we distribute and multiply 2 binomials together, we always have like terms right here in the middle, right? So what's negative 3x minus 2x? These boulders are sure in my way. Okay, guys, what's negative 3x minus 2x? It's not negative 6x, no. Negative 3 minus 2. Negative 5x. Okay? So that's, yeah? Yeah, we always find our like terms and put them together. Okay, so this is the product. Now we have to write the excluded values. The easiest way to write excluded values is to come back to the parentheses. Remember, we can't have the denominator equal 0. So what would make this factor equal 0? What number minus 2 equals 0? 2. So x can't equal 2. Also, x can't equal whatever would make this factor 0. 3. Any questions how we got 2 and 3 as the factors, or as the excluded values that can't equal 0? Yes. -1? Oh, because that's in the numerator. The numerator can be 0. It's just the denominator. Okay? Because if you have 0 pizzas divided by, say, 5 people, how much pizza is every person going to get? 0. But the difference is if you have 5 pizzas and no people, how much pizza is no people going to get? Does that make, it doesn't make sense, right? That's why we can't divide by 0, because it's undefined. But we can have 0 on the top, and that's fine. Okay, let's try another multiplication problem. Example number 2. Okay, again, find the product and state excluded values. The first fraction is 3x squared divided by x plus 2. Times, the second fraction is x squared plus 3x plus 2 divided by x. Okay. On the first problem, what did I ask us to do at the very beginning? Parentheses. Do you see any binomials for us to put parentheses around? X plus 2, right? So put parentheses around x plus 2. I actually claim with a little manipulation we can find 2 more binomials. What else would we get 2 more binomials to put parentheses around? Because we want to find pairs that cancel out, yeah? This one? Yeah. Can't we do our favorite F word, which is factor, right? And we'll get 2 more binomials. So that's what we're going to do. Because we're looking for, it'd be nice if we had something that canceled out. That is a good one, right? As long as we say it correctly. All right. Since x squared doesn't have a coefficient in front that's larger than 1, we can go straight to the x. This is the easy kind. We just have to think, what 2 numbers multiply to 2 and add to 3? It's Jaden, right? Yeah, okay. Can you think of 2 numbers that multiply to 2 and add to 3? It's not 4. Don't listen to him. That's silly. What times what is 2? 1 times 2. And 1 and 2, do those add to 3? Yeah, right? So those are our numbers. X plus 1 and x plus 2. Do you see something? Do we have a match? Yeah. We can cancel if we have a match top and bottom and their neighbors are being multiplied. So just double check. Is x plus 2 being multiplied to x? Yes. Is x plus 2 being multiplied to x plus 1? When we have 2 parentheses next door like that, that is times. So we are allowed, it's legal, for us to cancel those out. Is there any other matches that could cancel out? There is. Look closer. There's one more cancellation. Look closer. Huh? X plus 1 doesn't have a match in the denominator. The only thing left in the denominator is an x. What could x cancel with, Nathan? The x squared, right? Is x squared being multiplied to the 3? Is x squared being multiplied to the x plus 1? Yeah, then we're allowed to cancel. But here's the tricky part. How many x's are down here? There's only 1. So if we cancel 1 out, we can't cancel 2 out up here. We only cancel 1 of them. So to show that you're canceling 1, you just scribble out the 2, and then there's 1 left, right? If we take away the squared exponent, there's 1 left. So on the top we have 3x times x plus 1 remaining. Is there anything in the denominator remaining? No, not at all. So let's, again, find the product. Turn to your neighbor and tell your neighbor what the product is. Turn to your neighbor and tell your neighbor what the product is. Okay, those are 5 in your row. Make sure the middle person had someone to talk to. Plus, that's only half of it, right? 3x times x is 3x squared. But then, what's 3x times the 1? Oh, nope. I thought I made a boo-boo, but I didn't, because remember right here, we canceled it out, and now it's only 1x. Because when we canceled this x, we canceled off the square. So it is still 3x. Okay, so 3x times x becomes 3x squared, and 3x plus 1 is plus 3x. But let's talk about excluded values. X can't equal. The easiest way to find excluded values is go back to the factors. Okay, you can look at these or these. Right here it tells us that x cannot be what number? Good, -2. And guess what? This is also a factor. So what do we find out x cannot equal? Because it would make the denominator 0 right here. 0, right? This x can't equal 0, or the fraction's undefined. So our excluded values are -2 and 0. Are you feeling more comfortable on excluded values? You just have to go back and find those factors at the denominator, in the denominator. Okay, we're going to try some division now. Yeah, that was just multiplication. But guess what? Isn't division almost the same as multiplication? Yeah, what's the only difference? Flip at the beginning, and then it becomes a multiplication problem. So it just has one extra step, but then it's the same. Okay, example 3. Division. Okay, we're going to do this one, and then the last one we do is going to be one straight off your homework. So, pay attention for that one. Alright, which one do I want to do? This looks good. 4k plus 8 divided by 6k minus 10. 4k plus 8 divided by 6k minus 10. That fraction will be divided by k squared plus 6k plus 8. K squared plus 6k plus 8 divided by 9k minus 15. Divided by 9k minus 15. Okay. What's the first thing we're supposed to do? Before that. What's the first thing I've asked you to do in every problem? Put parentheses. Wherever there's a binomial. They're everywhere. Right here, right here, right here, right? Okay, now because it's division, what do we need to do? Flip and multiply. Okay, here's the other phrase I learned yesterday, and it's just genius. I thought it was fabulous. Okay, and maybe you've heard it. Copy, dot, flip. I kind of like it a little bit better because then there's not confusion of which one do I flip. Because you copy the first one, then you put a dot, and you flip the second one. Copy, dot, flip. So let's do that. 4k plus 8 over 6k minus 10 gets copied. What does the dot represent? Multiplication, and then you flip the second one. So now 9k minus 15 is in the numerator, and the trinomial goes in the denominator. K squared plus 6k plus 8. Copy dot flip. I think I actually like that a lot better than flip and multiply. Yeah, let's put those parentheses in. Okay, currently, do we have any binomials that cancel out? Yes. Do we have any binomials that have a match, top and bottom, that can... No, we don't, right? But with some manipulation, I bet we could find some. Where could we manipulate either the numerators or the denominators? Paula? Okay, we could have a trinomial here, right? Which we could factor. What two numbers multiply to 8 and add to 6? Allison, can you tell me two numbers that multiply to 8? 2 and 4, do those add to 6? 2 plus 4? Yes, they do. Okay. So, Allison, how do I write those as my factors? With a K. K, 2, and? Good. Aha, we have some binomials. Okay. Still doesn't match any of those 3 binomials. Can we manipulate a little bit more? So this is what math teaches you. It teaches you how to manipulate things. Right? Can we manipulate this one? 9k minus 15. I think we can. It's called factoring, our favorite F word. 9k minus 15. Is there anything that factors out? 3. If we factor out a 3, it means we divide each piece by 3. Okay? So M, we're going to divide each piece by 3. What's 9k minus 3? Or, sorry, divided by. 9k divided by 3. Not subtract, divide. 9 divided by 3. 3, 6, 9, so it'd be 3k. And what's 15 divided by 3? Or 3 times what number is 15? 5. Okay? It's looking better. All right. What about this one? Can we factor anything out of this one? 4k plus 8? Yeah, 4 factors out, right? Okay. Chibs, if we divide out a 4, what would be left? Divide both by 4. Good. Oh, we have our first match. I see it. Yep. I'm going to factor the last one before I start canceling things out, though. Adam, what could factor out of these two? 2, and what would be left, Adam?
5.
I agree with the 5. I don't agree with just k. What's 6 divided by 2? 3k. There we go. All right, let's start seeing. Oh, we have another match? Good. We have a k plus 2. Let's check. Is its neighbor being multiplied? Is it multiplied to 4, and is it multiplied to the 3? Yes, so we are allowed to cancel. And this k plus 2 is multiplied on both sides? Yes, so it is legal to cancel if it's multiplication. You have to check that because if it's add or subtract, you're not allowed to multiply, or not allowed to cancel. Okay, you said there's another match, right? 3k minus 5, is it multiplied to its neighbor? And this guy multiplied to its neighbors? Okay, any other matches? There's no other matches, but I see someplace it can be simplified. Top and bottom. Look, what's remaining in the top? And what's remaining in the denominator? What could be simplified? Yeah? I'm sorry?
2.
Because where do you see 2 over 1? 4 divided by 2. Doesn't that divide? And becomes 2 over 1. So the 4 changes to a 2. So what we have left is 2 times a 3 over k plus 4. Does anyone have objections to that or have questions how we got 2 times 3 over k plus 4? Which becomes 6 over k plus 4. So that is our, it's not a product this time. What's the answer to a division problem? Quotient. That's the quotient. And let's find the excluded values. K can't equal -4. It also can't equal, go back to all the factors, it can't equal is not 2, -2, and the last one's a little tricky, so I'll write it out. Basically, we're saying it equal to 0. 3k minus 5, if we solve for k, divide by 3, which means k can't equal 5/3. So remember to go back to those, I'll just leave that there. Go back to those factors. Wherever there's a variable, you have to make sure the factor when it equals 0. So division is the same, except for we do a copy dot flip at the beginning. Okay, ready to get one from your homework? So the last one, and then we have tons of time to work on your homework, which is great. Okay, last one. This is called a complex fraction. It's actually just like number 3, example 3, but it's set up vertically. So it looks super complex, but it's the same thing we just did. Okay, the first fraction is g plus 2 divided by 3g minus 1. No. All divided by, so put a big fraction bar because we're going to divide by another fraction. That's why it's called complex. Looks complex, but it's really not bad. G squared plus 2g over 6g plus 2. See, it's actually the same as example 3. But example 3 was side by side. This one's up and down. So you survived example 3. So we're going to do the same steps on this one, even though it's up and down. Okay, what's the first thing we need to do in all of these problems? Parentheses, every time. Find those binomials. Binomials, wow, we have 4 binomials. Now with the division problem, when we have a fraction divided by a fraction, what do we need to do? How do we divide 2 fractions? Benita? Flip and multiply, or copy the first one. Yep, copy dot flip. Dot, flip the second one. So that means 6g plus 2 is now on the top. Copy dot flip. Alright, I think I'm going to let you and your neighbor work through this together. Because, see, it's just multiplication now. You just do that one little trick, copy dot flip, and you're back to a multiplication problem. Work with your neighbor. Make sure you're factoring. And try to simplify it, and then state excluded values. Work on the problem, please. Work with your neighbors. Find the things that need to be factored. Not all of them need to be factored. Why don't you tell your neighbor, because I don't hear much conversation, why don't you tell your neighbors which ones need to be factored. There are actually 2 that need to be factored out of the 4 binomials. Why don't you discuss with your neighbor and figure out which 2 of the 4 binomials need to be factored. Right. Which ones did you guys come up with to factor? 6g plus 2 and... I don't agree with that one. 3g minus 1. What could go into 3g and 1 besides 1? So, find the other one. It's not 3g minus 1. Yeah, because what do those have in common? What do they both have? G squared and 2g. What do they both have? They both have a G. So that's the right one. Alright. The 2 you should have found to factor was 6g plus 2 and g squared plus 2. So the first fraction is just going to stay the same for a minute. Six g plus 2. What can divide out of both of those? A 2. And making, if we divide and factor away a 2, what will be left? 3g plus 1. Excellent. Okay. And this guy, what do they have in common? Factor out a g. What does that leave us with? G plus 2. Okay. Once you factor, you should start seeing some cancels. Do we have any matching binomials or anything that simplifies? G plus 2, because its neighbors being times. G plus 2, its neighbors being times. What about these two? G plus 1 and G minus 1. No, they're close, but unfortunately not close enough. So, that's the only cancel we get. So on the top we have 2 times 3g plus 1 remaining. And in the denominator we have a g and 3g minus 1 remaining. Should we leave our answer like that? No. To take them back and distribute them back. So that just takes us back to 6g plus 2 that we had at the beginning. And takes us back to 3g squared minus g. That's a plus. Sorry, that doesn't look like a plus sign. Okay, excluded values. G cannot equal, well, look right here. This is a factor. What number can this g not be? Because it would make the fraction, what? 0. G cannot equal 0. So make the fraction undefined. Now this one's a little trickier. This one you can't really do in your head. Some of you, after some practice, can do it in your head. If you don't know, solve it, set it equal to 0 and solve it. Yeah, it's a fraction, 1/3. Oh, I missed one. Which one did I miss? Oh, wasn't there another factor right here? -2. There we go. Okay, so that's off your homework. It's probably the hardest one on your homework. So we've just done the hardest problem. Congratulations. Okay, so the assignment for tonight is, where is it? There it is. Page 348, numbers 1 through 15 all, 17 through 27 odd. Okay, just as a reminder, you are to do this on paper, not in the book, but on separate paper. You should write down the problem, you should show work, and box up the answer. Okay? You're free to work with your neighbors as long as you're working and not socializing. There's a difference between working and socializing. Make sure you state excluded values if it's requested. Carefully read the directions because it doesn't always ask you to write excluded values. You can if you want. It's good practice. But if it doesn't ask you to state excluded values, then you don't actually have to. Okay?